Hello and welcome. We are doing lesson 5 today. It is on solving word problems. These are all going to be written in linear form. Later we'll do word problems that are done in other types of forms. But as far as linear form, the linear equation, these can involve some substitution in order to solve, and some of the other things that we've learned. First of all, we're going to review some strategies for solving word problems. We have 5 steps of strategies here. First of all, of course, you need to read the problem carefully several times. Just keep reading it until you can state in your own words what is given and what the problem is looking for. And as far as what the problem is looking for, you need to assign a variable to represent the unknown quantities. This can often be found in the last sentence, or at least that's a good place to start. Sometimes you need to add some other variables as necessary. Step 2 and 3 kind of go together. You write expressions, which means there's no equal to sign, for any unknown quantities. If you can quickly think of an expression, you can write it that way, or you can write it as an equation. That means with an equal to sign. Step 4, solve the equation and answer the problem's question. And step 5 is check the solution in the equation and in the original wording of the problem. So we're going to begin, and we're going to go through all of these steps with our problems. So the first one is the median, which essentially means middle, starting salary for a business major exceeds that of a psychology major by $8,000. The median starting salary for an English major exceeds that of a psychology major by $3,000. And combined, their median starting salaries are $116,000. Determine the median starting salary for a psychology major, business major, and English majors with bachelor's degrees. So we know we're trying to find these 3 salaries. So our variables are going to represent, at least we're going to have variables to represent the median salary for the psychology major, the median salary for the business major, and the median salary for the English major. And I found that in the last sentence, which was telling me what I'm trying to find or determine. I'm going to assign variables for all 3 of the unknowns that I'm trying to find. We'll make X be the business major salary, starting salary, Y the psychology major starting salary, and W will be our English major. Next, we're going to assign some equations or expressions to this. So if we look at the problem again, here where it says the median starting salary for a business major exceeds that of a psychology major by $8,000. So it means if we knew what a psychology major's starting salary was, we would add $8,000, and that would give us a business major's salary. Or stated in terms of English, or my understanding of this is the business major salary is $8,000 plus the psychology major salary. Since I decided that X was my business major, that equals Y, which is my psychology major, plus $8,000. So this is written in terms of math. And then there's another sentence, there's a couple of them. The median starting salary of an English major exceeds that of a psychology major by $3,000, which means the English major's salary is $3,000 plus the psychology majors. So W was the variable we assigned for English major, Y, psychology major, plus our $3,000. And then we said for the passage read, combined, their median starting salaries are $116,000. So that means if we add all 3 salaries up, we get $116,000. Since we don't know the salaries, we put W plus X plus Y equals 116,000. Now we're going to solve the equation, and the first thing I want to do is use substitution. So I'm going to begin with the equation W plus X plus Y equals 116,000, but I have already found W. I've already found W and X written in terms of Y, so I'm going to substitute those in. For W, I'm going to put Y plus 3,000. For X, Y plus 8,000. And then just keep Y, Y. Next, I'm going to combine my like terms and solve. So I've got 3 Y's, and then 3,000 plus 8,000 is 11,000. So I have 3Y plus 11,000 equals 116,000. Subtract 11,000 and divide by 3, and I get 35,000. And that's what Y equals, which I have to then remember meant the median starting salary for a psychology major. Now that is only telling me what my psychology major is making, the average the psychology major is making. I need to take another equation, and I'm going to use the one that says, I could have used either of the first two, but I'll use the one that says X equals Y plus 8,000. I substitute 35,000. I substitute 35,000 in for my Y, and then I solve that, which we know how to solve that just by adding those two together, and I get 43,000, which is my median salary, or the median starting salary for a business major. Then I need W, so I'm going to take the next equation, and the second equation I had come up with was W equals Y plus 3,000, and again I'm going to substitute the known value of 35,000 in for my Y value. So I have W equals 35,000 plus 3,000, which is 38,000, so the English major's median salary is 38,000. Now let's go back to the actual problem and check and see if our solution makes sense. The median starting salary of a business major is 43,000. This is 8,000 more than a psychology major who makes 35,000. And that makes sense that 8,000 plus 35,000 is 43. The median starting salary for an English major is 38,000, which is 3,000 more than a psychology major makes, which does add up. And combined, they should make 116,000. And if I add up everything I got, that is true. So it looks like my answer checks. And of course, for a word problem, we always do want to write out what our answer means, which was when we put the median starting salary for a psychology major is 35,000, the median starting salary for a business major is 43,000, and the median starting salary for an English major is 38,000, because the question said, what is the median salary, starting salary for all three? Okay, let's go to example 2. Researchers have surveyed college freshmen every year since 1969. The attitudes about some life goals have changed dramatically over the years. In particular, the freshman class of 2009 was more interested in making money than the freshman class of 1969 had been. In 1969, which seems to be my starting point, 1969, 42% of freshman students considered being well off financially essential or very important. For the period from 1969 to 2009, this percentage increased by approximately 0.9% each year. If this trend continues, by which year will all college freshmen consider being well off financially essential or very important? For this problem, we have to again look at and try and see if we can figure out, well, what are we even trying to find out? What is the unknown quantity we want? And this last sentence, once again, the last sentence says, if this trend continues, by which year will all college freshmen consider being well off financially essential or very important? So we're looking for a year. But this can be a little confusing because we're not actually going to be able to make an equation with our year. We're going to make X the number of years since 1969. But we have to remember that ultimately we need to know the exact year that all college freshmen consider being well off financially essential or very important. Okay, let's try and make some equations. One thing that people don't always know is that the rules for an equation and what we're allowed to add and subtract are the same as our like term rules. In other words, we have to have like terms. We have to have like units. If we're going to add two numbers, they have to have the same unit. I can't say 42% plus $69. That doesn't add up that way. I can multiply or divide unlike units, but I cannot add or subtract unlike units. Things have to be the same. So I'm going to look at this sentence here. In 1969, 42% of freshman students and then another fragment of another sentence increased by approximately 0.9% per year. So we started with 42% in our beginning year, 1969, and we added 9% per year, 0.9% per year. So just looking at that phrase, we can say that 42 plus 0.9x, x being the number of years. So if it was just 1 year, I'd add 0.9, 2 years, 1.8, 3 years, 3 times 9 is 2.7, so I'd add 2.7, and so on and so forth. Notice I didn't change these, but I could have. I could have changed these to 0.42 and 0.009, but I did not, because I know that I'm going to be able to cancel that decimal idea. So the question, though, wants to know, when will all freshmen, which means 100% of freshmen, believe that or feel that being well off financially was essential or very important? So this is going to tell us when we reach 100%. So my equation is going to be 100 equals 42 plus 0.9x. And I can double check to make sure that's okay by looking at my units. 100 was a percent, 42 was a percent, 0.9 was a percent per year, which means divided by year, and then x represents a year, the number of years. So if you recall, with your fractions, let's look at how that part of the equation still is only a percent. So we're going to turn it into an equation. So 0.9 is a percent per year, which means percent divided by year, and then we're going to multiply that times the number of years, so our unit for that is year, and then we can cancel year for year, and then all we're left is percent. So always when we're adding, our equation should have adding the same unit to the same unit, like terms. It's like terms once again, and that's going to tell us that our equation equals that same unit. So always keep that in mind. It's a good double check. Sometimes you can even figure out how to set up an equation knowing that. So this is a pretty easy equation to solve. You subtract 42 from both sides and divide by 0.9, and we get x equals 64.4, which needs to be interpreted. What does that mean? So remember that x represented the number of years, and we're beginning in year 1969, so we're going to add 1969 plus 64.4 years, which is the year 2033, somewhere almost halfway in the middle of that year. So the answer is that in year $2,033. Okay, we're going to do another one. Example 3, you are choosing between two texting plans. Plan A has a monthly fee of $20 with a charge of $5 cents per text. Plan B has a monthly fee of $5 with a charge of 10 cents per text. Both plans include photo and video text. For how many messages will the cost for the two plans be the same? Here's your question, so we know we need a variable to represent the number of texts in order to be able to answer that. So that's the first variable. Just knowing a little bit, I know that I also don't know how much plan A cost or plan B, so I'm going to make those A and B variables also. So I'm going to have three variables. The variable X represent the number of texts, A, the total monthly cost of plan A, B, the total monthly cost of plan B. And going from steps 2 and 3, now I'm going to make expressions and equations. The question says that plan A has, which is a form of the word is, which means equals. So plan A equals $20 per month plus 5 cents per text. And that can be written A equals $20 plus 5 cents per text. So when we write an equation for plan A, has, remember, is equal to, or it's a form of the word is, which means equal to. So A equals $20 plus our $5 per text. And checking the units, plan A, we're talking about the cost, so that was dollars. We can look back and to see what A represented, and it was a cost. $20, we know unit had a unit of dollars. $0.05 per text. So dollars per text, X represents the number of texts, so we're multiplying that by text. And again, we can cancel the unit text with the unit text, and that is also a dollar amount. So we're actually saying that the dollar amount equals a dollar amount plus a dollar amount. For plan B, we're going to similarly say plan B, or B has, which means equals, has is a verb to be, the monthly fee of $5 plus $0.10 per text, and we're multiplying the 10 cents times how many texts we have. So the 10 cents was dollars per text, not just dollars, but dollars per text. And X represented the number of texts, so we cancel those out, and ultimately it's a dollar. So again, we have dollar plus dollar equals dollar. Now we need to solve this problem, and what the question asks us is when the plans cost the same. So when does plan A cost the same as plan B? In other words, when does A equal B? So again, we have a substitution problem, but we're going to take what we said A equals and put it here, and what we said B equals and put it here. So A equals B becomes 20 plus 0.05x equals 5 plus 0.10x. And then we just solve that by rearranging it so we can combine our like terms using opposite operation, and then finding that x equals 300. And when we put that 300 back into the word problem, we realize it means that at 300 text messages for plan A and for plan B, the cost will be the same. Okay, let's try another one. Your local computer store is having a terrific sale on digital cameras. After a 40% reduction, you purchased a digital camera for $276. What is the camera's price? So we're trying to find the camera's price before the reduction. You know, after the reduction it was $276, but what was it before the reduction? So in other words, what was the original price of the camera? And we're going to assign the variable P for that. You can assign any variable. That's step 1. Step 2, we need to come up with some equations. So remember, really you just have to realize if you were going into a store and you were getting 40% reduction, you would take the original price and subtract 40% of the original price. And that should get you $276 in this case. So we have assigned the variable P for the original price. So we're going to take P and subtract 4% of P. And that should give us the sale price, which is $276. So now all I have to do is solve that. P minus 0.4P is 0.6P, and dividing by 0.6 I get $460, which means that originally the camera cost $460. And you would want to realize that obviously that original cost is more than the sell cost, so kind of double check that, and it is. Alright, let's do another one. Your grandmother needs your help. She has $50,000 to invest. Part of this money is to be invested in a non-secured bond, paying 15% annual interest. Annual is an important word, meaning every year. The rest of the money is to be invested in a government-insured certificate of deposit, that's a CD, paying 70% annual, again per year, of interest. And she told you that she requires $6,000 per year in extra income from the combination of these two investments. Combination meaning we got to add how much money we're getting from each together to get $6,000. How much money should be placed in each investment? So we're looking for total. We're looking for money for each investment. So we have to have two variables here because we have two investments. And the question one might ask is, why wouldn't you just invest it all at 15%? Because it's more money, so it seems like it would be better. But because this is non-insured, there is some risk. So when we do, there's a lot more risk to investing in something that's non-insured. So we don't want to invest all of our money there. We don't want to put all of our eggs in that basket. However, for the purpose of this problem, we're just going to say nothing went wrong and all the money invested made what it was supposed to make. We need two variables, one representing the 15% non-insured bond and the other representing the 7% CD from the government that is insured. So we'll use A and B. A being the amount invested in the non-insured bond, paying 15%, and B is how much is invested, money invested, so dollar amount, in the insured CD, paying 7%. The more detail you get in defining your variables, the easier it is later to go back and to look at it and put the right context when you go back and look at your problem. So it's actually a very good idea to put a lot of detail in when you're defining your variables. Something you may not know is that the amount of simple interest that is made on this account can be found using the formula I for interest equals PRT. I for interest equals the principal times the rate times the time. In this case, interest is how much your grandmother is going to get. And that equals the principal, which is the amount she invested, times the rate, the interest rate as a decimal, times the time, which in this case is going to be 1 year. So T equals 1. Now, she's got 2 accounts earning interest. So once we find the amount of interest for one account, we have to add it to the amount of interest to the second account. Okay, so interest is going to equal our principal times our rate times 1 for 1 year. But because we're looking at 2 interests, we're going to add them. We're looking for a total interest, so we're going to add the 2 together. We're looking at the amount we invest in account A, that's our principal, times the interest rate as a decimal, 0.15, times 1 year, plus the amount we invest in account B times the interest times 1 year. We also have to remember that the problem tells us the total interest. It's the amount that Grandma needs. The amount she gets will hopefully be what she needs. She needs $6,000. So we're setting this equation equal to 6,000. 6,000 equals A times 0.15 times 1 plus B times 0.07 times 1. Now the second equation we're going to find is, sometimes it's so easy, sometimes we overlook it. So let's go back up here. A is the amount invested in one account. B is the amount invested in the second account. And remember the total amount invested in both accounts. How much does Grandma have to invest total? She has $50,000. So A plus B is going to give us $50,000. The amount she invests at 15% plus the amount she invests at 7% equals $50,000. So we can say that with another equation. A plus B equals $50,000. And I'm going to rearrange that equation to be, I'm going to subtract B from both sides so that I solve it for A. A equals 50,000 minus B. You could have subtracted A and said B equals 50,000 minus A, but we're going to do it this way. It doesn't really matter which way we do it. And now we're going to use some substitution. So we have the first equation, 6,000 equals A times 0.15 times 1 plus B times 0.07 times 1. We also know that A equals 50,000 minus B, so we're going to substitute A right here for 50,000 minus B. That is our A value. And then everything else comes down, times 0.15 times 1 times 0.15 times 1 plus B times 0.07 times 1. So let me just line that up. So that part's the same. Really, and the 0.15 times 1 is the same. So everything in the equation is the same, except for A has been replaced with 50,000 minus B. Now we know that 0.15 times 1 is just 0.15. This is actually a distributive property. So we are distributing this 0.15. So we're doing 0.15 times 50,000. 0.15, it's the whole thing really, 0.15 times 1, but that's 0.15. 0.15 times B. So 0.15 times 50,000 is 7,500, and 0.15 times B is just 0.15 B. So that becomes 6,000 equals 7,500 minus 0.15 B, and then of course we had the 0.07 times 1 times B, and that we just cleaned up. Now we're going to combine these two terms Remember, that's a negative 0.15 times a positive 0.07. Which is 0.08, so that's, or negative 0.08, so it's a negative 0.08. So we have 6,000 equals 7,500 minus 0.08. Subtract the 7,500, divide by negative 0.08, and we end up with B equals 18,750. And then to find A, we got to remember that A plus B equals 50,000. Plugging B in for B, and then solving gives us that A equals 31,250. And what that means, as far as checking it, is that $18,750 needs to be invested at 77% interest in the government CD, and $31,250 needs to be invested at $15,000 in the unsecured bonds. Okay, we're going to look at another one. I think this is our last one, example 6. The length of a football field is, which is usually an equal to sign. So the length is 200 feet more than the width. If the perimeter of the field is 1,040 feet, what are the dimensions? We do have to know a few things. One, we have to know a football field is a rectangular shape. So when we say dimensions, we're looking for the length and the width. Those would be the dimensions. And perimeter, we'll put P for perimeter, is equal to 2 lengths plus 2 widths. Because the perimeter is just if I were walking around the outside of the football field. So I'd have 2 lengths I'd be walking and 2 widths. So that's my perimeter. Well, I've kind of jumped ahead. My variables are going to be P and L and W. So length would be L, W would be width, and then we'll use P for perimeter. And I already said my equations. P equals 2L plus 2W, but remember, I already know what P is. P is 1040. The problem told me that. So I'm going to substitute 1040 in there, and I'll get 1040 equals 2L plus 2W. And then that first sentence, the length of the football field, length, L, the length of the football field, L, is 200 feet. More than means to add the width. So L equals 200 plus W, and 1040 equals 2L plus 2W. So again, let's substitute what L is, 200 plus W, in for L. So we have, when we substitute in for L, 200 plus W. So we have 2 times 200 plus W, the quantity of 200 plus W, plus 2W. We're going to distribute our 2, giving us 400 plus 2W. And now we can combine our like terms and subtract 400 from both sides, divide by 4, and we get that W equals 160. And then since we know that 200 plus W equals L, we just put our 160 in for W, and we get that L equals 360. And going back to the problem, of course, to check that, we realize that we're talking about feet. So the football field, has a length of 360 feet and a width of 160 feet. And those are our dimensions. And that concludes our lesson on word problems. Basically, these are applications of linear and systems of linear equations. And there was a lot of substitution there, so go on to your MyLabs Plus and practice and make sure you can write the equations, you can substitute the equations. We've combined pretty much everything we've been doing. And so now's the time to really practice it, since a lot of people tell me they're not very good with word problems. So that means you have to practice. And if the ones I gave you on MyLabs Plus is not enough, you can go and bring up your textbook on MyLabs Plus and look at the practice problems that are given to you there.